Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over another gas stoichiometry problem. So let's get into this. So we're going to first start by reading the problem. So here we're given a regular antacid tablet, and we're told that this antacid tablet or a regular antacid tablet will react with about 80 milliliters of 0.050 molar HCl. How many milliliters of this CO2 gas at 37 degrees Celsius and 1.02 atmospheres will form from the complete reaction of 80 milliliters of 0.050 molar HCl? Okay, and then they give us the equation. Here we have the balanced equation for the reaction. So let's get in this. So when we're doing stoichiometry, remember we want to convert from one thing to another using the balanced equation. The reason we're using the balanced equation is because we're going to get our mole ratio from the coefficients in the balanced equation. So in this reaction, we're looking for, or in this particular problem, we're looking for the amount of the amount of the antacid tablet, right? So the amount of gas that's going to be formed from its reaction with HCl. So we want to go from amount of HCl to amount of carbon dioxide gas. So whenever you're going from one thing to another, you're going to have to use the mole ratio, which means we're going to have to convert to moles first. So whatever unit you're given, you're going to convert to moles. So here I have our major highway here. So here's the highway, the main highway, and then we got these off roads. We got these side roads here, right? So where are we beginning? We're beginning with a volume. We've got a volume of an acid that has a molarity. So whenever you're given molarity, you want to use that as a conversion factor because molarity is moles per liter. So anytime you have something per something, that's going to be used as a conversion factor. So we've got a volume here. We can use the molarity to convert the volume to moles. So here, right, we're given some unit of a liquid, right? We're going to have to convert that to liters and then use the molarity to convert to moles. Once we're at moles, we can now use the mole ratio to convert from moles of substance 1 to moles of substance 2 and then go from there. What are they asking for us? They're asking for the amount of, where is it? Where is it? Oh, so how many milliliters of CO2 gas? So we want milliliters of CO2 gas. So here, we're going to have to go this way. So we're going to have to use PV equals nRT to convert the moles of gas, CO2, to liters, and then convert that to milliliters, which is the volume unit that they want. So using our roadmap, we could figure out what these steps are going to be. So we're going to start with the amount of HCl they're giving us, 80 milliliters. We're giving 80 milliliters of HCl. So we're going to start with 80 milliliters of HCl. And we're going to have to convert that to liters because remember, molarity is going to help us get to moles. That is the goal. So the use of molarity as a conversion factor is to help us go from liters to moles. And those are the units of molarity, moles per liter. So in order to use molarity, we need to convert this to liters. So we're going to do our next step. So I know that there's 1,000 milliliters in a liter, or you can say 1 milliliter is equal to 10 to the negative liters, because a milliliter is 1/1000th of a liter, right? So either way works. We could do 1,000 milliliters or 10. Oops, excuse me. Sorry about that. So this is going to be 10 to the third milliliters. 10 to the third is 1,000. And then on top, we're going to have 1 liter. And this is going to be HCl, we might identify this as a solution, HCl solution instead of HCl. Okay, and so this is liters of HCl solution. So the milliliters is going to cancel out. Now we have liters. Now we can use the molarity. So we're given the molarity of 0.050 molar. So that's 0.050 moles per liter. So we have liters on top. So we're going to put 1 liter on the bottom. So 1 liter of HCl solution, and we're going to have 0.050 moles. So 0.050 moles of HCl. So I've gone from the HCl solution to HCl in the solution. And so now liters of the HCl solution cancel out. Now I have moles of HCl. Now I am here on my road map. So now I'm on the main highway. So here, I started with milliliters, converted to liters. Now I'm here with moles of substance 1. Now I'm going to use the mole ratio to convert to substance 2, which in this case is carbon dioxide gas. So I need to use the mole ratio between these two. So I have 2 HCl and I have 1 CO2. So it's 2 to 1. So I'm going to do my 2 to 1 ratio. So it's going to be 2 moles of HCl on the bottom because I have moles of HCl on top. Those are going to cancel out. And I have 1 mole of CO2 on the top. So moles of HCl will cancel out. And now I have moles of CO2. Now I'm here at moles of substance 2. And now I want to get to the unit they're asking me for, which is milliliters of CO2 gas. So I'm going to have to start this way. I got to use my ideal gas law equation to convert moles to liters. So again, you can stop here and just calculate the number of moles and then plug that into the ideal gas law, right? Solve for the volume, use that to then find the volume in liters, and then you would convert that to milliliters. But you could also just use it as a conversion factor, right? So you can use the R value, right? So if we use the R value for as a conversion factor, as a complex conversion factor, we could just put that in for the conversion. So we have moles on the top, so we want moles to cancel. So we'll put 0.0820058, and then the units are going to be liter atmospheres on the top. Here, I'll write this down here to give myself some room. So we'll continue down here. So I have 0.0820058, and then this will be liter atmospheres over, and then we have mole Kelvin. So this is my conversion factor. So moles are going to cancel out. So this is moles of CO2 that we're talking about. So moles are going to cancel out here. But then we need to get Kelvin and atmospheres to cancel out, leaving liters. Well, where are we going to get Kelvin and atmospheres? Well, that's from the problem. They gave us the conditions here, 1.02 atmospheres. So we're going to multiply, right? We're going to multiply and divide so we can get rid of atmospheres in Kelvin. Well, first we need to change the temperature from Celsius to Kelvin. So let's do that. So 37 degrees Celsius plus 273.15. That's going to give us 283.10. So that's going to be 310.15 Kelvin. So since Kelvin is on the top, we're going to put that, since Kelvin's on the bottom, we're going to put this on the top. So we're going to multiply by 310.15 Kelvin. Kelvins are going to cancel out. And then what we can do is we are given the atmospheres 1.02 atmospheres. We have atmospheres on top, so we want to put the 1.02 atmospheres on the bottom. That'll cancel out. And then we're left with the liters. And so then, now since we have liters left, now we have to convert liters to milliliters. And so we're going to go back to this relationship here, but we're going to flip it this time. So here, so we're going to have, since we have liters on the top, we're going to put milliliters on, we're going to put liters on the bottom. So 1 liter of CO2. We're talking about CO2 gas now, right? So here we have CO2 gas. And then we have 10 to the third milliliters of CO2 gas on the top. So liters are going to cancel out, and we're left with milliliters, which is what they're asking for. How many milliliters of CO2 gas? So this is done here. Again, there's multiple ways you could do this. Again, what I said is before, you could have stopped here, calculated the moles of CO2, and then plugged the moles with the temperature and the pressure here. With the temperature and pressure here, and then plug that into the PV equals nRT, solve for volume, and you would have got liters. And then you could just convert using this step here, convert the liters to milliliters, and you would get the same answer, right? So, and there's another way to do this as well, but I chose to do it this way. So just because. So now all I need to do is multiply across the top by everything and divide by the bottom by everything, and I should get my answer. And when I do that, I get 50 milliliters, 50 milliliters. And so why 50 milliliters? Well, if you look at the number of sig figs, we'll have to go back here. For those of you who are interested in the number of sig figs, remember that the rule for multiplication and division is that when the number of sig figs in your answer should be the same as the number of the sig figs in the measurement with the least number of sig figs. So let's look at the number of sig figs that we have here. So let me take a look. And so we look here, this actually has 1 sig fig here. Don't mistake the 0 for a sig fig because there's no decimal point here. If there's no decimal point at the end of the number, that 0 is not significant, or it's at best ambiguous. So here we only have 1 sig fig. This relationship is exact, so we'll ignore that. Again, this is exact, we'll ignore that. The molarity here, that's got 2 sig figs. The 1-to-2 ratio, that is exact, so we'll ignore that. This has, 5 sig figs. This has 3 sig figs. This has 5, and so the lowest number is 1. So then that means that our answer should only have 1 sig fig. So you'll notice that there's a 50. There's no decimal point at the end of the number here. So this 0 is not significant. So that is 1 sig fig. So this is going to be 50 milliliters of CO2 gas is formed. And that, ladies and gentlemen, is how you do gas stoichiometry. I hope this was helpful. If you enjoyed this video, if this helped you in any way, then please like the video, share the video with your friends, hit that like button. Also, subscribe to my channel, please. And then when you do, make sure you click make sure you click the bell, the notification bell. And when you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question that you need help on and you would like me to go over it, I would love to do that for you, as well as going over any topics you would like me to go over. Thanks for joining me, and have a great day.